Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Sound, Class 9, Chapter 12. In-text questions. How does the sound produced by a vibrating object in a medium reach your ear? When an object vibrates, it forces the neighboring particles of the medium to vibrate. These vibrating particles then forces the particles adjacent to them to vibrate. In this way, vibrations produced by an object are transferred from one particle to another till it reaches the ear. Second, explain how sound is produced by your school bell. When the school bell vibrates, it forces the adjacent particles in air to vibrate. This disturbance gives rise to a wave, and when the bell moves forward, it pushes the air in front of it. This creates a region of high pressure known as compression. As you can see here, when the bell moves backward, it creates a region of low pressure known as rarefaction. As the bell continues to move forward and backward, it produces a series of compressions and rarefactions. This makes the sound of bell propagate through air. Third, why are sound waves called mechanical waves? Sound wave forces the medium particles to vibrate. Hence, these waves are known as mechanical waves. Sound waves propagate through a medium because of the interaction of the particles present in that medium. Fourth, suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? Answer: sound needs a medium to propagate. Since the moon is devoid of any atmosphere, you cannot hear any sound on the moon. Fifth, which wave property determines A. loudness, B. pitch? Amplitude. The loudness of the sound depends on its amplitude. If the amplitude of sound is large, then the sound produced will also be loud. Frequency. The pitch of the sound depends on its frequency. A sound will be considered high-pitched if its frequency is high. 6. Guess which sound has a higher pitch, guitar or car horn? Sound of guitar has a higher pitch because sound produced by the strings of guitar has higher frequency than that of a car horn. 7th, what are the wavelength, frequency, time period and amplitude of a sound wave? Wavelength. The distance between two consecutive compressions or two consecutive rarefactions is known as wavelength. Its SI unit is meter. Frequency. The number of complete vibrations or oscillations per second is known as frequency of sound wave. It's measured in hertz. Time period. The time taken to complete one vibration or oscillation is called time period. It is measured in seconds. Amplitude. It is the maximum displacement of the particle of the medium from their mean position to original position at rest. You can see amplitude, wavelength and time period in this graph. Here you can see high frequency waves and the low frequency wave. 8th, how are the wavelength and frequency of the sound wave related to its speed? Speed, wavelength and frequency of the sound are related by the following equation. Here speed is equals to wavelength into frequency. 9th, calculate the wavelength of the sound wave whose frequency is 220 Hz and speed is 440 meter per second in a given medium. We know that speed is equals to frequency into wavelength. So putting the values, we can get wavelength is equals to 440 upon 220, that is 2 meters. 10th, a person is listening to a tone of 500 Hz sitting at a distance of 450 meters from the source of sound. What is the time interval between successive compressions from the source? The time interval between two successive compressions is equal to the time period of the wave. This time period is reciprocal of the frequency of the wave and is given by the relation T is equals to 1 by F. So from here we can get frequency 1 by time period. Putting the values, we get 0.002 seconds. 11. Distinguish between loudness and intensity of sound. So the difference between loudness and intensity is, loudness is the sensation of hearing, where sound ranges from quiet to loud. Intensity is the sum of sound energy that travels into our ear per second. Loudness is the correlated with sound wave amplitude. Intensity is the rate at which the power is transmitted over given region. Unit of loudness of sound is decibel. Intensity of sound is measured in watt per meter square. Loudness of sound vary for different per people. Intensity of sound is same for everyone. Loudness depends on the responsiveness of human ears. Intensity of the sound is independent of any hearing sensitivity. 12th, in which of the three media, air, water or iron, the sound travels the fastest at a particular temperature? Sound travels fastest in solid, its speed decreases in liquid and slowest in gases. Therefore, sound travels fastest in iron. 13. An echo is returned in 3 seconds. What is the distance of reflecting surface from the source given that the speed of sound is 342 meter per second? Given the speed of sound is 342 meter per second, time here is 3 seconds. So, the distance travelled by the sound is equals to speed into time. So distance is equals to, putting the values, we get 1026 meter. In a given time interval, sound has to travel a distance that is twice the distance of the reflecting surface and the source. Hence the distance of the reflecting surface from the source is equals to 1026 by 2, that is 513 meters. 14. Why are the ceilings of the concert hall curved? The ceiling of the concert halls are curved so that the sound after reflection from the walls spread uniformly in all directions. 15th, what is the audible range of average human ear? The audible range of an average human ear lies between 20 Hz to 20,000 Hz. 16th, what is the range of frequencies associated with A. Infrasound, B. Ultrasound? A. Infrasound has a frequencies less than 20 Hz and ultrasound has frequency more than 20,000 Hz. 17th, a submarine emits a sonar pulse which returns from an underwater cliff in 1.02 seconds. If the speed of sound in salt water is 1531 meter per second, how far is the cliff? So given here, the time taken is 1.02 seconds. Speed of sound here is 1531 meters per second. So the distance will be speed into time. So putting the values here, we get 1561.62 meters. So the distance travelled by the sonar pulse during its transmission and reception in water is twice the actual distance. So actual distance will be distance of the cliff from the submarine upon 2. So dividing 1561 by 2, we get 780.31 meters. Now back exercises. First is what is sound and how it is produced. Sound is a form of mechanical energy which gives the sensation of hearing. It is produced by the vibration caused in air by vibrating bodies. 2. Describe with the help of diagram how compressions and rarefactions are produced in air near the source of sound. When a vibrating body moves forward, it creates a region of high pressure in its vicinity. This region of high pressure is known as compressions. When it moves backward, it creates a region of low pressure in its vicinity. This region is known as rarefactions. As a body continues to move forward and backwards, it produces a series of compressions and rarefactions, which is shown in the figure below. Here you can see compressions and rarefactions. Third, cite an experiment to show that sound needs a material medium for its propagation. So you can see the diagram here. You have to take an electric bell, airtight bell jar connected to a vacuum pump. Then suspend the bell inside the jar and press the switch of the bell. You will be able to hear the bell ring. Now pump out the air from the glass jar. The sound of the bell will become fainter and after some time the sound will not be heard. This is because almost all the air has been pumped out. This shows that the sound needs a material medium to travel. Fourth, why is sound wave called a longitudinal wave? Sound wave is called a longitudinal wave because it is produced by compressions and rarefactions in air. The air particles vibrate parallel to the direction of the propagation of the wave. Fifth, which characteristics of the sound helps you to identify your friend by his voice while sitting with others in a dark room? The quality or timbre of sound enables us to identify a friend by his voice. Sixth, a flash and thunder are produced simultaneously, but thunder is heard a few seconds after the flash is seen. Why? The speed of the sound, 344 meter per second, is less than the speed of light, which is 3 into 10 to the power 8 meter per second. Sound of thunder takes more time to reach the earth as compared to light. Hence, a flash is seen before we hear the thunder. Seventh, a person has a hearing range from 20 Hz to 20 kHz. What are the typical wavelengths of sound wave in air corresponding to these two frequencies? Take the speed of sound in air is 344 meter per second. So when the frequency is 20 Hz, given speed of sound in air is 344 meter per second. So now we know that speed is equals to wavelength into frequency. So from here we can find out the wavelength, which will be speed upon frequency. Now putting the values over here, we get wavelength is equals to 17.2 meters. Similarly, when the frequency is 20 kHz, wavelength will be speed upon frequency, which is 20,000 kHz here, 20,000 Hz. Putting the values, we get 0.0172 meters. Hence, a person's hearing range of wavelength is 0.0172 meters to 17.2 meters. 8. Two children are in opposite ends of an aluminium rod. One strikes the end of the rod with the stone. Find the ratio of time taken by the sound wave in air and in aluminium to reach the second child. So the speed of sound in air is V1, which is 346 meter per second. Speed of sound in aluminium is V2, which is 6420 meter per second. Let the length of the aluminium rod be x. So we know that speed is equals to distance upon time. Hence time will be distance upon speed. So time taken in air is equals to x by 346. Time taken in aluminium will be x by 6420. Now required ratio will be x by 346 upon x by 6420. So now opening the equation we get 18.55. So the required ratio will be 18.55 is to 1. 9. The frequency of the source of sound is 100 Hertz. How many times does it vibrate in a minute? We know that frequency is equals to number of oscillations upon time. So number of oscillations will be frequency into time. Now putting the values over here, we know that 1 minute is equal to 60 seconds. So we'll get number of oscillations 6000. 10th, does the sound follow the same laws of reflection as light does? Explain. Yes, sound follows the same laws of reflection as that of a light because angle of incidence of sound is always equal to that of angle of reflection of sound wave. And second, the direction in which sound is incident, the direction in which it is reflected and the normal all lie in the same plane. 11th, when a sound is reflected from a distant object, an echo is produced. Let the distance between the reflecting surface and the source of sound production remains the same. Do you hear echo sound on a hotter day? An echo is heard when the time interval between the original sound and the reflecting sound is at least 0.1 second. The speed of sound in a medium increases with increase in temperature. Hence, on a hotter day, the time interval between the original and the reflected sound will decrease. Therefore, an echo might not be heard on a hot day, as echo can be heard only if the time interval between original and reflected sound is greater than 0.1 second. Now give two practical applications of reflection of sound waves. Reflection of sound is used to measure the distance, direction and speed of underwater objects. This method is known as sonar. Working of stethoscope is based on reflection of sound. In a stethoscope, the sound of patient's heartbeat reaches the doctor's ear by multiple reflection of sound. 13th, a stone is dropped from the top of the tower 500 meters high in a pond of water at the base of the tower. When is the splash heard at the top, given that acceleration due to gravity is 10 meters per second and speed of sound is 340? So we know the height of the tower, which is the distance, is 500 meters. Velocity here is 340 meters per second. Acceleration due to gravity is given 10 meters per second. Initial velocity of the stone is 0 since the stone is initially at rest. Time taken by the stone to fall to the base of the tower will be t1. So according to the second equation of motion, which is S is equals to ut plus half at square, putting all the values over here, we get t1 square is equals to 100. So t1 will be 10 seconds. Now time taken by the sound to reach the top of the base of the tower is t2, which is 500 upon 340, which is equals to 1.47 seconds. Therefore, the splash is heard at the top of the time, at the top after time t, where t is equals to t1 plus t2. Now putting the values over here of t1 and t2, we get time 11.47 seconds. 14th, a sound wave travels at a speed of 339 meters per second if its wavelength is 1.5 centimeters. What is the frequency of the wave and will it be audible? So the speed of sound is 339 meter per second here. Wavelength is 1.5 centimeters, which is 0.015 meters. Now speed of sound is equals to wavelength into frequency. We know that. So putting the values over here, we get frequency is equals to speed upon wavelength. Now putting the values over here, we get frequency 22,600 Hertz. So the frequency range of audible sound for human life is between 20 Hertz to 20,000 Hertz. Since the frequency of the given sound is more than 20 Hertz, it is not audible. 15th, what is reverberation and how it can be reduced? The repeated multiple reflections of sound in any big enclosed space is known as reverberation. The reverberation can be reduced by covering the ceiling and the walls of the enclosed space with sound absorbing materials such as fiberboard, rough plastic, heavy curtains, cushion seats, etc. 16. What is loudness of sound? What factors does it depend on? The effects produced in the brain by the sound of different frequencies is called loudness of sound. Loudness depends on amplitude of vibration. In fact, loudness is proportional to the square of the amplitude of vibrations. Explain how bats use ultrasound to catch a prey. Bat produces high-pitched ultrasonic squeaks. These high-pitched squeaks are reflected by objects such as sprays and returned back to the bat's ear. This allows a bat to know the distance of its prey. 18th, how is ultrasound used for cleaning? Objects to be cleaned are put in a cleaning solution and ultrasonic sound waves are passed through the solution. The high frequency of these ultrasound waves detaches the dirt from the objects. 19th, explain the working and the application of a sonar. Sonar is an acronym for sound navigation and ranging. It is an acoustic device used to measure the depth, direction and speed of underwater objects such as submarine shipwrecks with the help of ultrasounds. It is used to measure the depth of seas and oceans. As you can see here, a beam of ultrasonic sound is produced and transmitted by the transducer, which is a device to produce ultrasonic sound of sonar which travels through the sea water. Now the echo produced by the reflection of this ultrasonic sound is detected and recorded by the detector, which is converted into electrical signals. The distance d of the underwater object is calculated from the time taken by the echo to return with speed v is given by 2d is equals to v into t. This method of measuring distance is also known as echo ranging. 20. A sonar device on a submarine sends out a signal and receives an echo 5 seconds later. Calculate the speed of sound in water if the distance of the object from the submarine is 3625 meters. Now the time to hear the echo is 5 seconds. Distance of the object from the submarine is 3625 meters. So the total distance traveled by the sonar wave during the transmission and reception is 2 into d. So velocity of sound in water will be 2d upon t. So putting the values, we get velocity of sound 1450 meter per second. 21. Explain how defects in metal blocks can be detected using ultrasound. Defects in metal blocks do not allow ultrasound to pass through them and they are reflected back. As you can see here in the picture, this fact is used to detect defects in metal blocks. Ultrasound is passed to one end of the metal block and detectors are placed on the other end. The defective part of the metal blocks does not allow the ultrasound to pass through it. As a result, it will not be detected by the detector. Hence, defects in metal blocks can be detected using ultrasound. 22. Explain how the human ear works. As you can see in the diagram, the human ear consists of three parts: outer ear, middle ear and inner ear. Outer ear. This is also called pinna. It collects the sound from the surrounding and directs it towards the auditory canal. Middle ear. The sound reaches the end of the auditory canal where there is a thin membrane called eardrum or tympanic membrane. The sound wave sets this membrane to vibrate. These vibrations are amplified by three small bones: hammer, anvil and stirrup. Inner ear. These vibrations reach the cochlea in the inner ear and are converted into electrical signals which are sent to the brain by auditory nerve, and the brain interprets them as sound. Thanks for watching. Please do like, share and subscribe.